Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think yesterday we have discussed about the application of IR spectroscopy. There are I think 5 applications we have discussed with the help of some suitable example. Let's revise that application once again. Number 1, determination of structure. It is one of the application of IR spectroscopy. Number 2, study of progress of chemical reaction. That will be the second application of IR spectroscopy. And third one we have seen detection of hydrogen bonding. Fourth one, detection of the ring size. And the last one, detection of the impurities. These are the some of the important application we have learned, we have discussed yesterday. Student, what we are going to discuss, let's discuss over here. That is a illustrative examples, means solve example we are going to study here. Illustrative examples, illustrative examples means solve examples we are going to discuss over here. Let's see the example number 1. What is that? Number 1, an organic compound, having molecular formula C3H6O, which is a given formula, shows bands at bands at 1720 per centimeter and 2720 per centimeter in its IR spectra. Find out the structural formula of the compound. Find out the structural formula of the compound. Find out the structural formula of the compound. Now, if you read the structure carefully, what do you observe over here? See here. An organic compound having molecular formula C3H6O shows bands, IR bands particularly, at 1720 per centimeter and 2720 per centimeter in its IR spectra. Find out the structural formula of the compound. Now, how do you answer this, or how will you answer this? This as far as the organic chemistry is concerned, or in every spectroscopy, you have to come across such a type of the problems. So how to solve these problems? There is definite rules for solving the problem, and you can arrive at the correct structure or the probable structure of the unknown compound. That will be the final goal or aim of this type of the, because in the problem they have provided necessary things required for it, partial information are given, and from that, by thinking logically, you can arrive at the final structure. And while solving the problem, the first point to find out the structural formula of the compound, as we know that structural formula, this is the molecular formula, and there are the different number of structure we can assign for this. Suppose, let me give you here some examples which containing, because do you remember as a isomer? Isomer means the organic compound having general formula, same molecular formula but different structures are known as a isomer, and that phenomenon is known as isomerism. Now suppose, let us see, there is this formula is present, there are 3 carbon atoms are there. Suppose we can show these 3 carbon atom in the straight way, and there let's see 1 oxygen atoms are there. So that oxygen atom we can put here, suppose as a C double bond O H, and here as we know that CH3, here maybe as a CH2. Look at here, one structure is this one, another structure we can call for we can draw for this CH3, then CH3, this is a second structure, or another structure we can draw for the CH2 double bond CH, then CH2O. This will be the structure number 3. Look at here, 1, 2, 3 carbon atom, 1 oxygen atom, 6 hydrogen atom, here also has a 6 hydrogen atom, 3 carbon atom, 1 oxygen atom. If you remember, if you see here, count the number of carbon atom, 1, 2, 3. Count the number of hydrogen atom, 2, 3, 4, 5 and 6. Look at 1 oxygen atom. So this is the third structure. Again we can draw this structure CH2 double bond CH, then O CH3. This may be as another structure. This structure may be a fourth structure. Look at here, 3 carbon atom, 1, 2, 3, 6 hydrogen atom, count here, there is 2, 3 and 3 are 6, 1 oxygen atom. This is a probable structure 4. Or we can draw another structure also, CH to then CH, here may be 1, 2, 3 and 4, here CH3. Look at here, this is a structure number 5, right? Look at here, count the number of carbon atom, 1, 2, 3, hydrogen atom, 2, 3 and 3 are 6, 1 oxygen atom. And one more structure can you draw? Yes, we can draw another structure over here, this one, CH2O, then CH2, CH2 and O. This will be the another structure, structure number 6. Is there any possibility? Can you draw one more structure over here. Yes, we can suppose these are the different structures. See here, there are the 6 structures. Let's see over here. We have drawn, or we can draw another structure also. This CH, not this CH2, then here CH2, then CH, like this, and there may be here O 2 to 4 5 and this 6, right? This may be as another structure. Look at here, 1 2 3 carbon atoms, 3 carbon atoms are there, and another one. This is a structure number 7, structure number 7, this one, structure number 7, 1 2 3 7 structure number. Can you draw another structure for this? Okay, these are the different 7 structures having the molecular formula is the same, C3H6O. Look at here, there are the 7 different structure, probable structure. Out of these 7 structure, which one will be the correct structure? So look at here, from this, which one will show you the correct structure of that organic compound? We cannot decide, but here we know that there is a band, right? 1720 per centimeter. Another is given here 2720 per centimeter. And from these 2 bands, we can easily come to know that which will be the correct structure of the organic compound. Do you know? Listen here, from these 2 structures, this is, as we know that by observing the characteristics table of IR frequencies, the 2 distinct peaks here is 1720 per centimeter, which is due to the carbonyl group, as we know that. And another one here, look at this one also having as a carbonyl group, this one also having as a carbonyl group. No other element shows as a carbonyl group. Here ester, here also as a ester, here alcohol, here alcohol. Means from this, if you see this structure is ruled out. This is also as a ruled out. This is also as a ruled out. This is also as a ruled out. By observing that band, probable we are looking only 1720 per centimeter. This is due to the presence of carbonyl group. One structure containing as a carbonyl group here, and another second structure also containing as a carbonyl group, C double bond O. Now, if you think this structure also has a ruled out, structure number 3 to 7, all are the ruled out because there is a no signal. The structure number 3 to 7 will not show signal at 1720 because by observing as a characteristics table of IR frequencies, we know that the band appear around 1720 per centimeter due to the carbonyl group. It is a characteristic band of IR stretching frequencies, and from that, if you observe all these structure, only 2 structure showing that functional group which is a carbonyl here also and here. Now among these two, another characteristic peak is given here, which is at 2720 per centimeter. Again go back to the characteristics table, see, observe there carefully, and while observing you will find there the band in between 2720 to 2900 per centimeter. This is the band due to the aldehydic CH stretching frequency. Look at here, means now among these two, one which is appear around 1720 per centimeter, this is also as a 1720 per centimeter, 1720 per centimeter, but additional recognizable peak among these two, this is due to the aldehydic 2720 per centimeter, and both the peaks are present. And as we know that aldehyde group is always present at the end of the carbon compound, and therefore the structure must be first one and not the second one. This is a probable. But before that, what is important while solving such type of the problem? So first, while solving this problem, while answering this problem, first thing to calculate the sites of unsaturation. Sites of unsaturation. Sites of unsaturation. This is the first point we must determine, or we must find out how many sites of unsaturations are present in the given organic compound. So it is important one sites of unsaturation. Unsaturation means what? The organic compound containing, let me tell you, the organic compound containing carbon-carbon double bond. If carbon-carbon double bond, carbon-oxygen double bond, carbon-nitrogen double bond, carbon-sulfur double bond, or any ring such as 6-membered ring, maybe as a 4-membered ring, 5-membered ring, 3-membered ring, or this type of the rings are present in the organic compound. Remember here, it means that there is a one site of unsaturation, SOU. One site of unsaturation. Remember, this is a very important tips and the trick to calculate or to remember the site of unsaturation. Here, site of unsaturation is carbon-carbon double bond or carbon-oxygen double bond, or maybe as a ring, any heterocyclic ring you can say this also, or maybe as a this type of the ring, or maybe as a nitrogen, this type of the NH, this type of the ring, all are exhibit one site of unsaturation. Remember, or maybe as a this is a piperidine, as we know that all are the site of unsaturation, or maybe this one, this is a piperidine, pyrrolidine, or this type of the compound maybe as a this tetrahydrofuran THF, generally we are calling it. So this type of the compounds are present, they show, they exhibit one site of unsaturation. This is the one thing. Again remember, if the carbon-carbon triple bond or carbon-nitrogen triple bond, how many sides of unsaturations are there? There is a 2 sides of unsaturation. Remember here, if there is a carbon-carbon double bond, carbon-nitrogen double bond, it means that there is a 2 sides of unsaturation. Unsaturation means what? They are the organic compound containing double bond or the multiple bond. That type of the organic compound is called as unsaturation. But in this case, if a ring is involved, that is also termed as a sites of unsaturation. Look at here, only one ring is present. Either it may be 3-membered ring, 4-membered ring, 5-membered ring, 6-membered ring, 7-membered ring, that correspond to one site of unsaturation. That you have to keep in mind. If carbon-carbon double bond, carbon-nitrogen triple bond, if triple bonds are there, it is nothing but as a 2 sides of unsaturation. Now as we know that benzene, look at here, benzene, what do you think? Benzene, how many sides of unsaturation are present in the benzene? What do you think? There will be 4 sides of unsaturation, SOU, 4 sides of unsaturation. How? Look at here, carbon-carbon double bond, single bond, double bond, single bond and double bond. There are 3 carbon-carbon double bond and 1 for ring, and therefore total site of unsaturation account for benzene is a 4. If site of unsaturation is a more than 4, probably the organic compound shows as a aromatic compound. That you should remember. These are the 3 things you should remember while counting the site of unsaturation, because we are going to find out the sites of unsaturation. There are various methods to find out the sites of unsaturation, but at T.Y.B.Sc level 2 methods are there. Out of the 2 methods, we are going to discuss only one method, how to calculate site of unsaturation for the given organic compound, that we are going to discuss here. While solving the spectroscopic problem from the given data, the first important thing is to find out the sites of unsaturation in the given compound. And there are 2 important methods. How many methods are there? There are 2 important methods. The UV and IR spectroscopic information is more useful in finding the electronic environment of the proton. The UV and IR spectroscopic information help us to find out the position of different functional group, while PMR spectroscopy, that we are going to discuss after completing this chapter. But for the sites of unsaturation, that we are discussing how to calculate, that one that we are discussing. The intensity of a signal, that is area under the signal, gives us the idea about its number of each kind of proton. Thus the combined information of UV, IR and PMR make it much easy to find out the structure of unknown compound. Sites of unsaturation, method number 1 we are going to discuss. This method is most commonly used. According to this method, following changes are made. Now let us see over here. This is the general information I have given here. In addition to that, now the one method which we are going to discuss over here, this one, method number 1. Here, method number 1 which we are going to discuss, and this is this method is most commonly used. According to this method, following changes are made. Number 1, here we are going to make one table. You can remember this table here. So in the middle one, that you can make it as a big one. Then there is a 3. Okay, now look at here. A, now each O or S atom, each O means oxygen or sulfur atom, then if it is present in the molecular formula, neglected, you neglect it, neglected. And in the second point, each nitrogen atom is replaced by CH. This one, A, B and C here. Now each Cl, Bri are replaced by hydrogen only. Replaced by hydrogen. Understood this one? This is the first method. In the second method number 2, only remember, let me give the second number here, just method number 2. Each oxygen or sulfur atom is replaced by CH2, that is the change, and each nitrogen atom is replaced by CH, and each chlorine, bromine, iodine are replaced by hydrogen atom. So that will be the second step. Now, how do we solve this? Let's see over here how we can solve this. How we can calculate the site of unsaturation by using as either first method or second method. Let's see over here. Now, while calculating as a site of unsaturation, remember here, according to as a first rule, what is that? The molecular formula is given here. Molecular formula is given C3H6O, right? Now, according to as a first point over here, neglect the oxygen atom, the molecular formula becomes C3H6, right? Now, according to general formula of alkane, remember here, alkane, what is that? CnH2n+2, which is a general formula of alkane or for saturated. Now here put n is equal to 3 here, number of carbon atom, so that becomes C3H8, right? Then from this minus this one C3H6, so just do the mathematical. C3 cancel here, 8 minus 6 remains as a 2, remember, and 2, whatever remains 2 divide by 2, the answer comes is equal to 1, and therefore the site of unsaturation for this organic compound is a here 1. You have to write here is a 1 site of unsaturation is there. So in this way you can calculate the site of unsaturation of the organic compound. Understood this one? Site of unsaturation 1 means this one may be, I just now told you that carbon-carbon double bond, carbon-oxygen double bond are there may be as a ring, and this is a very very important one as per this is the first point. We have calculated site of unsaturation, we have got here is a 1. Now let's see second point, site of unsaturation is equal to 1. Now let us see as a second point. Second point, what is there? The IR absorption band. The IR absorption band at 1720 per centimeter indicate presence of C double bond O stretching frequency. Understood this one? Now say a third point you can write. Third point, the IR band at the IR absorption band or you can call it as a peak, or you can call it as a signal at 2720 per centimeter suggests the presence here stretching frequency of carbonyl group may be aldehyde or ketone. Here the IR absorption band or peak or signal at 2720 per centimeter suggests the presence of aldehydic this one CH stretching frequency. Got it? And now, and therefore the probable structure, by considering all above points, we can assign the following structure of the given organic compound. Therefore we can CH3, CH2, C double bond O and H. This is the structure. This is a 1720 and this will be 2720 per centimeter. So in this way we can easily find out the correct structure of that organic compound. So I think this is one of the example we have solved with the help of this, and now in the next lecture we will solve some more example. Till then, stop today here. Thank you. Have a nice day.